Hello fellow problem solvers. So today we're going to be doing a problem from the 2016 European Girls Math Olympiad, problem number 1. This is a beautiful problem which I suggest you try out for a minimum of 30 minutes, ideally an hour and a half to 2 hours, but not more than 3.5 hours. If on the other hand you'd like to go along with us, I suggest you take a preliminary look for the next 20 minutes. And now, without further ado, let's begin. So, this is the thing we are really given. We have numbers x1 through xn, they are non-negative real numbers, and we can, let's say, put them on a circle, and we must prove that the smallest of the two consecutive sum of squares is less than or equal to then the largest of the product, twice the product of the two neighbors. And we also have the fact that n is odd, and this is important for some reason. Like, that might give us a hint, like, wait, we should maybe try out the evens and see why don't the evens work as well. Either way, the first really easy thing for me to do is to say, like, what's the contrary? The contrary is that the smallest one of these xi plus 1 squared is greater than or equal to then the biggest one of the two xj plus 1s. Which really means that if I take any xi squared plus xi plus 1 squared, it's going to be greater than or equal to 2 times xj plus 1 for any j. Like, that is what the converse really is. Because if you think about the maximum, like, if the maximum is greater than or equal to this one, and the minimum is greater than or equal to this one. So we can really try to prove the converse. Like, it makes sense, actually, strictly. We have strict inequalities here. And with that, like, something about n being odd is useful. So now I invite you here to pause and think about this for the next 10 minutes and try to push the problem further. And what can you do if you want to get a sense of the problem is, play around. Let's say n equals 3. You have numbers a, b, c on a circle. And you know that, say, so a squared plus b squared is going to be greater than, okay, let's say 2ab is going to be easy, but let's say 2bc. And what does this mean? Well, what could this mean, actually? Let's think about this. Well, what I'm thinking of initially is, what if b is the biggest one here? Say if b is the biggest one. Actually, no. What if c is the biggest one here? Then this is false. So wait a second. Does that really just finish the problem quickly? Because wait, if c is the biggest one of all these numbers, then we have c times, but then I know that c times b, I know this is greater than b squared, if c is the biggest one, and actually if c is just bigger than b, then I know this is true. So it must be the case that a squared must be greater than c times b, which means that, so c is greater than b. Well, for this to hold true, it can be actually in between them. It could be like it just needs, like, a needs to be greater than their geometric mean. Interesting. But let's assume this to be the case. We also need a squared plus b squared to be greater than 2ac here. And this also needs to be the case. Now, we know that a is greater than, is a greater than b? I think a definitely needs to be greater than b. We know this is greater than b, so a is greater than b. So now, what does this mean? Well, we have a times c. Well, this is greater than b squared. So that means that a times c needs to be less than a squared. So a needs to be the biggest one here. Interesting. So now we know that a is greater than c is greater than b. Okay, so now we have some new progress. But wait a second, this gives us a contradiction straight away, right? Because now we have c squared plus b squared needs to be greater than 2ac, which is just false because ac is greater than b squared and ac is greater than c squared. So a contradiction, I guess. And with that, that's 3. So now, why does 4 not work? Like, why can't, actually, the opposite question is, like, why can 4 work? Let's think about, well, maybe just let me try AB. What do I need now to happen? I need to have a squared plus b squared needs to be greater than 2ab. This is actually always the case. So this thing works out, like, no matter which two neighbors I choose, they're going to be a squared plus b squared, and no matter which two neighbors I multiply, they're going to be ab. So I guess I see why the evens will work. out, like y for n even, this isn't necessarily the case, because if a and b are different, we're done. And now with these hints, I invite you to take another like 5 to 10 minutes, maybe play around with 5 of these numbers on a circle and push the problem further. Now here's the next step. So when we have 5 numbers, we have A, B, C, D, E. Let's say A is the biggest. And now we have these things that are true. And they give us an ordering. They give us A is greater than C is greater than B. And similarly, A is greater than D is greater than E. And now the question is, okay, let me now take 2CD is less than the sum of, say, B squared plus C squared. And 2CD is greater than the sum of E squared plus D squared. And now if C is greater than D, I have this is greater than 2D squared. And then we have E squared plus, we have then say E squared is greater than D squared. E is greater than D. A contradiction because we found that D was greater than E. So it seems like somehow, like maybe 5 is an edge case, but somehow we are having these changes of a big one, a small one, a big one that's bigger than these two, then this one needs to be bigger than these two. And now the question is this a fact just because of 5, or can we generalize this? And now I invite you with this hint to just pause for another 5 minutes and see if you can generalize this. Here's the next step. And once you let x1 be the max, you try out this first thing and you get x1 is greater than x3 is greater than x2. And then you're looking for the next sort of inequality if you can get it. And you see, wait, if x4 is greater than or equal to x3, then from this thing right here, we would have a contradiction. We would have that this whole thing would be greater than or equal to this thing. So we have x3 is greater than x4. This is greater than x2. This is less than x1. And now the thing is, can we continue doing this? That's the question. Can we now go to x5? Can we make sure that x5 satisfies this relationship? Can we? I invite you to pause for 3 minutes and try to do that. And the thing you need is you have x5 squared plus x4 squared. This needs to be greater than or equal to, actually strictly greater than 2 x4 x3. And this, I believe, works. Oh, wait, what does this give us? This gives us, because x4 is the smallest one, doesn't give us anything, so we need a different one. Let's see, x3 squared plus x4 squared. Now we have this, and greater than or equal to 2x4 x5. Can this give us anything? What if x5 was actually smaller? What sort of contradiction could we get? Oh wait, could we get a contradiction here? If x5 was smaller, then we would have this is greater than or equal to x4 times x4 squared plus x4 x3, and we would have this thing is greater than x5 squared plus x4 squared, just from this thing right here. So we also know that x5 needs to be less than x4, and now a pattern emerges that we can prove inductively, and the pattern is that x2 times I plus 1 needs to be greater than x of 2i plus 2 and less than x2i plus 3, and so on and so forth for every I. But then, because n is odd, we will have that x1 is greater than x2, less than x3, greater than x4, so on and so forth until xn minus 1, and we have xn. And what will we get for xn? Well, this is odd. What's happening to odds? Odds are greater than their neighbors. And now we run into a pickle. Now this is greater than x1. And now if we apply the same rule here, we can keep applying the rule, like this is a circle. So now we'll get x2. And it's a contradiction right here. So this actually solves the problem. And now with that, I invite you to take 5 minutes and try to write it up. Here's the write-up. So we say that because n is odd, there exists an I such that either this is true, case 1 or case 2. Otherwise, we'd get a contradiction in 2 different ways. This means in case 1, we have this is greater than or equal to this is greater than or equal to this, which is greater than or equal to the minimum of xj squared plus xj plus 1 squared. And again, the max is greater than this specific one is equal to this is greater than or equal to this is greater than or equal to this minimum. And that solves our problem. And as always, thanks for problem solving.